our next lesson is about direct variation. So there actually are a couple ways you can solve direct variation equations. I've actually just moved to teaching one way, which is always the easiest way. So direct variation problems are going to be real world problems that you're going to solve for some unknown. So here your distance from lightning varies directly with the time it takes for you to hear thunder. If you hear thunder 10 seconds after you see the lightning, you're about 2 miles from the lightning. How far is the lightning if you hear thunder 22 seconds after you see the lightning? So we're going to create a proportion. There's a couple different ways you can create a proportion. A proportion is just two fractions set equal to each other. You just have to remain consistent. So I know that if I hear thunder 10 seconds after I see the lightning, I'm 2 miles away from that lightning. So those two numbers are going to get paired together. So I'm going to take the 10 seconds and I'm going to put it over the 2 miles. I could flip both of these, put 2 miles on top, 10 seconds on the bottom, but when I write the second fraction, I have to put seconds on top and miles on bottom because that's what I did in the first equation, or the first fraction. So for my second set of information, I want to know how far the lightning is if I hear thunder 22 seconds after I see the lightning. So that 22 has to go on top because it's seconds. And then I'm going to put an X because X is what we're trying to figure out. We're trying to figure out how far is the lightning away from us, and we want to find that distance in miles. So here we just have a proportion to solve. The best way to solve a proportion is just by cross multiplying. So we're going to multiply these two things together, and it's going to equal these two things multiplied together. So I'm going to take 10 times x, which is 10x, and I'm going to take 2 times 22, which is 44. So then I'm going to take, to figure this problem out, I'm going to divide both sides by 10 to get x equals 4.4. Remember, x represented miles, so I'm going to label that miles. So if you hear thunder 22 seconds after you see the lightning, you are approximately 4.4 miles away from that lightning. Questions on this one? Moving on, so a recipe for a dozen corn muffins calls for 1.25 cups of flour. The number of muffin varies directly with the amount of flour that you use. How much flour do you need to make 60 corn muffins? So here I have a dozen corn muffins. A dozen is 12. So I have 12 muffins. Those 12 muffins call for 1.25 cups of flour. So I'm going to use muffins divided by cups. So when I set up my second fraction, I've got to put muffins on top and cups on the bottom. You could have put flour on the bottom instead of cups. Doesn't matter as long as you're consistent with those numbers. So if I want to figure out how many cups of flour, cups is going to be my x, and I want to make 60 corn muffins. So 60 muffins goes on top for that second fraction. Then I'm going to cross multiply. I'm going to multiply 12 times x to get 12x. And then I'm going to multiply 60 times 1.25 to get 75. To get x by itself, 12 is beside it, so I'm going to divide it. If I divide both sides by 12, I get x equals 6.25. Remember, x represented cups of flour. So if I want to make 60 corn muffins, I need to make sure I have 6.25 cups of flour. So 6 1/4 cups is what it would take to make 60 corn muffins. The next one, the force you must apply to lift an object varies directly with the object's weight. You would need to apply a 1/2 pound of force to a pulley to lift a 125-pound weight. How much force would you need to lift 500 pounds? So again, I've got this information here that belongs together. So I have a 1/2 pound of force with 125-pound weight. Make sure if you label these, if I label them both pound, I might get confused. So I'm going to label force and weight. So I have a 1/2 pound of force and 125 weight that I'm lifting. So when I set up my second fraction, I've got to use the pounds of force divided by the pound of weight I'm trying to lift. In this case, I'm being asked how much force would you need to lift 500 pounds? So I'm trying to lift a 500-pound weight and figure out how much force is needed. So with this one, I'm going to cross multiply. I'm going to multiply these two together. 125 times x is 125x. 500 times 0.5 is 250. Decided, divided, I'm going to divide both sides by 125 to get x equals 2. Remember that 2 represents the pounds of force that are required. So it would take 2 pounds of force to a pulley to lift 500 pounds. Two more. There is a question exactly like this on your next test. So the distance you travel varies directly with the amount of gas needed to get to your destination. You would need 20 gallons of gas to travel 500 miles. How many gallons of gas would be needed if you were traveling 750 miles? See if you can set up a proportion. So keep in mind, you want to keep things that go together. So I'm going to keep the 20 gallons with the 500 miles. So hopefully you said 20 gallons divided by 500 miles equals X gallons divided by 750 miles. If you flip both the fractions, you put miles on top, gallons on bottom, as long as you did it for both fractions, everything will work out just fine. At this point, you want to cross multiply. If I take X times 500, I get 500X. That's this diagonal right here. Then I'm going to set that equal to the other diagonal. I'm going to take 220 times 750, which is 15,000. Beside it divided, I'm going to divide both sides by 500 to get x equals 30. Remember, x was representing the gallons of gas. So if I was planning on traveling 750 miles, I would expect to need 30 gallons of gas to do so. And like I said a minute ago, there is a question exactly like this on your test. I even believe it talks about gallons of gas. I still think you're traveling, the numbers have just changed on how far you're going. And then the last one is the trickiest one. You do have a question, again, exactly like this on your test. It's again talking about some kind of flooring. But in this case, the cost of materials for laying carpet in a bedroom varies jointly. So instead of saying it varies directly, here we've said jointly, which means we're just going to have to join two things together in our proportion. In this case, it varies jointly with the length and the width. Those are the two things you're going to have to join together in your proportion. So here we're being told the cost of carpet for a bedroom with a length of 10 feet and a width of 12 feet is $403.20. All three of those numbers in this case go together. So those three numbers go together. We're talking about one bedroom. We were given the length and the width and the cost. So those three things are going to make up one side of my proportion. For the second side, I'm being asked what the cost would be if the room was 12 feet by 15 feet. So when I set up my proportion, I know that my length and my width have to be put together. So I'm going to use 10 length times 12 width. You don't really have to label the length and the width there, but I just want to label them so I make sure that when I do the top of the second one, I put the length and the width on top. So those two are joined together by multiplication. And then for the bottom, the only other information I know for that room is that it cost $403.20. So when I set up my second fraction, I need the length times the width on the top, which is going to be 12 times 15. And again, that was length times width. And then the cost on the bottom, the cost is actually what we're trying to find. So the dollar amount in the denominator. So for this, we're going to multiply, cross multiply. I'm going to take 10 times 12 times x. Well, 10 times 12 is 120 times x is 120x. For my other diagonal, I'm going to take $403.20 times 12 times 15. I can just type all three of those in my calculator all at once. That tells me 72,576. Yeah. To get x by itself, I'm going to divide both sides by 120 to get an x value of $604.80. Keep in mind, x was estimating the cost, so I'm going to put my dollar sign back with it, or you can put dollars out at the end. So notice for all of these, we've had some kind of label, be it dollars, be it miles, be it gallons of gas, something. Questions on this one?